Hello, my students. I wanted to help you with Chapter 6, using present value to make investment decisions. And the concept here is about present value. What is the present value of some future payment? If someone promised to give you $1,000 a year from now, that's not the same as giving you $1,000 today. It's worth less than $1,000 today, a promise to pay you $1,000 a year from now. If someone offered you to say, well, I'll give you $1,000 today, or I'll give you $1,050 a year from now, you would decide whether you would rather have the $1,000 now, which is less, but it's now, or $1,050 later, which is more, but it's later. So your calculation for doing that has to do with what you would consider the internal interest rate, or the interest rate discount rate that you would use. So if you took that 1,050 and reduced it by 10%, it would be less than $1,000 today. And so you would consider that $1,050 that's being paid out a year from now is not worth as much as $1,000 today, and you would take the $1,000 today. But if someone used a different sort of interest rate, let's say they only used a 1% interest rate like a bank might give you, you say, well, if I took the $1,000 today and put it in the bank, then 1 year from now, it would only grow by 1%. That would have only grown to $10 up. And that would mean that $1,000 today is only worth $1,010 10 years or 1 year from now, which it's better to wait a year and get the $1,050 if you were using a 1% rate. So the interest rate is really key, and the difference in what they have. So they explain that very well here, and they put it all out, and this is how they would show it, that $1,100 is equal to $1,000 times 1 plus the interest rate. Or another way of saying is that the future payment multiplied, this should be a division sign, 1,100 divided by 1 plus 10% is the $1,000. So that there's an error right here that should have a division sign in between there. And this also is repeated somehow when it came across on my on my screen. So it may have come across on your screen as well, that when you take the amount, and this should be a division symbol right there as well, so that because certainly $1 million times a positive number that's more than 1 is going to give you a value that's more than 1. But if you wanted to figure out what the present value of $1 million was paid out to a year from now, if someone said, I'll give you $1 million 1 year from now, or you can take a cash payment today, if you used a 10% payment, then you would get this value right here, a little over $909,000. Here, let me demonstrate by copying this over. And if we put this, let's say, into our Google search engine, and we remove that part of it, cut, then when they multiply it, they see that 1 million times 1.10, right? 1.10 is going to be 1.1 million, exactly what you expect. But if you divided it, that's when you would get the 909. You see, there's supposed to be a division symbol right there. So I thought that was useful for you to see. This is repeated. This kind of issue is repeated again down here when they show you about like growing $1,000 over a 2-year period. If you take $1,000, this is correct right here. What I'm showing you right here is correct. 1,000 times 1 and 0.10 times another 1.10. This is where you take $1,000, let it grow by 10%, and let it compound and grow by another 10%, will be worth 1,210, which is correct. But right here, 1,210 is not equal to 1,000 times 1.10 times 2. That is going to work out to being a gigantic number. I think that works out to 1,000 times 1.10 times 2 works out to I see there. This we'll put in the values here, and you can see what that would actually be equal to. Would be 2,200, which makes sense because you take 1,000, you raise it up 10%, and then you multiply it all times 2. The order of operations works in such a way that you'd get a totally wrong number. It's like doing it twice with the same, with $2,000 and growing it by 10%. What you want to do is change that to a little upswing like there. So it's a caret, or it turns the 2 into an exponent. When you do that, that's when you get the correct value of 1,210. So that means that you do the exponent first and then the multiply, if you remember your old PEMDAS. So that's actually how you do it. That's what it should be saying into here. There should be a little caret right there to show the exponent. And over here, there should be not only a caret for right there, but there also should be a division symbol there. So that's going to make it difficult. But despite the fact that the words in this Revel are good, those kind of things are errors that can be frustrating. Now, luckily you can find a lot of this information in other places, but this is one of the reasons I made the video for you. I also wanted to help you do the actual calculation, show you how to do it on Excel. So let me show you right here. Can you spot the difference of what the problem is with this formula? That's right. You need to have an exponent right there. That 3 is an exponent, not a factor. And right here, you'd need to have an exponent in front of the 3, because this is for 3 years, and there should be a division symbol there in order to make that a true statement. Okay, now this is a correct formula as it's written, but some of the examples that they gave are missing out. Like, for instance, since it's 25 years, whatever the years are have to be placed into an exponent, and the present value would then be discounted greatly. So if you took, for instance, 92,000, in order to make this correct, we'd put a division symbol between the million and the parentheses, and we'd put an exponent up in the 25. And that what we would say is if we took $92,296 and put it into a investment that earned 10% a year, and we left that $92,000 alone for 25 years, that it would be worth $1 million 25 years later. That's correct if there was, and that's a correct statement, the way that it would be mathematically written is though amended as I said. Now let's go ahead and try it. Here's a good example of how to use present value. You're thinking about selling. Well, let's first take it as a lottery winning, I guess, or win a contest, right? So you win $50,000 right away with 4 additional payments of $50,000. That's prize 1. And prize 2 is $175,000 right away. So is it better to take $175,000 right now, once and done, or is it better to take $50,000 a year for 5 years? 1 year, 1 right now, and 4 more in the next one. I put it into an Excel in the following way. So I said that the compare prizes, prize 1 is where we take $50,000 now and $50,000 each year for the next 4 years. Prize 2 is $175,000 now. Now the present value of prize 2 is easy. Prize 2, the present value is $175,000, because how much is $175,000 paid out to you today? How much is that worth to you today? Well, $175,000. But for prize 1, it requires some calculations. And I could show you this a couple of different ways, but I wanted to break it down so you can get an idea. The $50,000 that they're paying you now has a present value of $50,000. That doesn't matter whether they're paying 10% or paying 7%. They're just giving it to you right now, so the present value is exactly what they're paying you. But the $50,000 they're going to pay you 1 year from now, that's worth $45,454.55 to you right now if you use a 10% reduction. Because what that means is that if you took the 45, if you took this present value amount and grew it by 10%, it would be worth $50,000 1 year from now. So if someone says, I will give you $50,000 a year from now, or you could have $45,000 now, you would ask yourself, could I take that $45,000 and grow it to be $50,000 1 year from now? Would I be able to do that? Would I do that? Now, if you say, I can take $45,000 that you pay me and turn it into $50,000, and then to you, you're indifferent as to whether you take $50,000 later or $45,000 now. But if you didn't think you could get 10%, it would be better to take the $50,000 a year from now, because if they paid you $45,000 and you say you only got 5% return on your money or 2% return on your money, or lost the money, got a negative 5% or something like that. Well, you would have been better off waiting a year and just getting paid $50,000. This requires some amount of risk, but that's how you do the comparison. Over here, a $50,000 that they're going to pay you 2 years from now is only worth $41,000 this year, right now, this moment, and the $50,000 they're promising you 4 years from now is only worth $34,000. So since you got 5 payments coming to you, each one worth less than the next one because it's further and further away that they're paying you, the present value of those 5 payments today using a 10% reduction is $208,493. If you had used a 7% number, those same 5 payments are worth $219,000 to you. Now think about that for a second. Say, why, if I'm using a smaller interest rate, is the present value higher? The reason is that you having an expectation that the interest rate that you could earn on the money is low means that you don't have to work quite so hard to turn the money they give you into $50,000. So you're more willing to take the money now rather than wait. Right? If I said to you, would you rather have $45,000 now or $50,000 a year from now? You might be willing to take the 45. You'd be more willing to take the 50,000 a year from now because it's hard to turn 45,000 into 50,000. But it's not so hard to turn 46,000 into 50,000. Let's make another little chart here. Suppose we're only using, say, a 1%, right? If we did that, then we can copy this over and pop that in there and expand that. That's all that means. And then what we'll do is up here in the formula, we're going to change that from a 7 to a 1. This is a 1% number. And what we see here is that when we use a 1% discount rate, then that receiving $50,000 for the next 5 years is equal to $245,000 today using a 1.1%. So if someone said, I would give, what would you rather have, $245,000 today or $50,000 for the next 5 years? You'd say, well, as long as I can beat 1% return, it's better for me to take the $245,000. But if I can't do a 1% return, it would be better for me to take the stream of payments of $50,000. That's why when the discount rate or the rate of return is 10%, it's better to take the payments. It's better to take the $50,000. It's better to take prize 1 than prize 2. But when the numbers are over here and your values are only 1%, it's better to take the prize 1 if they offered you $245,000. Now, in this case, prize 2 is $175,000. So in order for prize 2 to be advantageous, we're going to have to use some value that is considerably higher than 10%. In order for 10% to make sense, we're going to just go ahead and copy this. We're going to pop that into here and again, expand that because that's the only problem there. And, let's say that we are using a 25% discount rate. Well, 50,000 paid out to us now is 50,000, but 50,000 paid out to us when we're using a 25% discount rate is 40,000. So if someone said, I'll give you 40,000 right now, or 50,000 a year from now, and you knew you could get a 25% return on your money, you'd consider 40,000 right now equal to 50,000 a year from now, because you at 25% you could earn 40. You could turn 40,000 into 50,000. And if we continue using that rubric, we can see that at a 25% return, that $168,080 is what their $50,000 paid out to you every year is worth to you. So if someone said to you, I will either give you $50,000 a year for the next 5 years, and you know you can get a 25% return, or they offered to pay you $175,000, then you would say, I would rather have the $175,000, because take a look at what you could do with $175,000. $175,000 at 25%, right? Can be 175 would grow and grow and grow and grow and be worth a lot more money than 250,000. Thank you.